Yeah, so can you hear me? Am I audible?
Yes,
Okay. Anything which you want to ask from the previous sessions? Some of you might be about to submit the assignment. Anything which you want to ask?
sir, just a quick question. Do we need to include the autocorrelation as well, or is it optional?
Include that would be better. I mean, after all, you are dealing with the time series data.
Sure. Sir, and for that, the p-value should be greater than 0.05.
Null of autocorrelation should be
Sure,
uh,
sir. Okay.
should not be rejected because null of there is autocorrelation. So that should be accepted partly. So we don't say accepted, I'll say there should not be enough evidence to reject that.
Okay, sir. Yeah. Thank you.
Hello, sir.
Yes.
So, in the coefficient discussion of output coefficients analysis,
Mm-hmm.
for coefficients relative importance for the impact of y on x, so do we look at the magnitude or, for example, do we look at the absolute?
Absolute value, not the sign. Sign signifies that it is adversely impacting, inversely related to the dependent variable. So if there is an increase in some coefficient which is negatively associated, so increase in x will lead to decrease in y. That is the interpretation of minus. Otherwise, when we want to know relative importance, we'll only look for absolute value.
Right. Sir, and for those variables which do not significantly impact the dependent variable, so for even that we have to interpret the result as such that an increase in that particular.
There's nothing wrong if you have theory to support that. There are two things. Suppose theoretically you find that some variable should be part of the regression, then you have them, even if they are insignificant, and you can talk about them, and then you so say that this variable is insignificantly related to dependent variable.
Okay.
Sir,
Yeah.
from the independent variables that I had taken for the assignment, two of them are marginally insignificant, like p-value is 0.6 and 0.06 and 0.065. So will you be
Yeah.
okay if I the model?
ठीक है. Let them be in the model. No problem.
Okay.
But reported that they are marginally significant. That's it.
Okay. Thank you.
So we'll start the topic. We finished last class on dummy variable application using example of cars and anything which you want to ask on that. I can understand you all of you must be engrossed completely with your assignment. But just recall last time we did caselet on cars and that caselet, if anyone has got any issue in understanding or some clarification, we had 54 cars data on these four heads, and then we tested. We tried to understand whether the road test score is significantly impacting the price or not. And we used the idea of median. We calculated the median value of road test score, and we gave all the cars having road test score more than median as a 1, and all the cars having road test score less than the median as 0. We made one dummy variable like that, and we run the regression, and we have tested whether there is a significant impact of high and low test score on the price or not, and we have found partly in both the cases second item was also significant. So that is something what we have done in the last class. So if anyone would like to ask anything or anything which you feel like talking again or we somehow missed last time. Right. So today we are starting CEO salary. I guess your CR would have requested you to go through it. And I believe that most of you have gone through it. So can somebody tell me what is the caselet CEO salary?
So basically, the case study talks about the various parameters on which the CEO salary is dependent, like CEO being at a high higher level in the demands a lot of salary. Even when the market, even when the organization not doing well, they take various increments. So it is question that should CEO get the salary, like if the case study is something like that.
I'm talking about the caselet which was related to dummy variable application. The next one. So anyone else would like to talk about it? I'm not much convinced with the previous explanation.
So, sir, I guess the salaries of the CEO across different industries are compared in this particular case.
Salaries of?
CEOs across different industries.
Okay.
So 4 industries are given and 209 observations are given across those industries, and we are asked to find the relation with the whether the CEO salary is related to the differ in the industry or not, and yeah. So basically, we have to uh, uh, find the relation between the industries and the salary, and whether it differs from industry to industry.
Uh, so what is the case which is in front of us talks about CEO salary. And if we look at the data, then data is like that. Mainly two main data, salary and rate of return over equity, ROE. You would have understood so far what is ROE. In numerator, we put net profit, and denominator, we have the owner's equity. And then we get to know how much return in terms of profit, net profit is coming from the investment in equity. So these two items are there. So if I just run a regression, then I would like to know what is the association between ROE with the salary, whether a company has high rate of return over equity is ready to give more salary to the CEO. That type of association we can find out. Let's try from that. And then if I just go through the case, then case says how the CEO's salaries may be dependent upon the sector in which he is working. And practically, we believe that sector-wise, salary of CEOs also change industry-wise. And right now, what we have done, we have taken the data of 4 industries: transportation, finance industry, consumer production, utility. This is the actual data which has been gathered from companies in US. And CEOs of these 4 industries, their salaries are there. And the caselet says we have been asked to prove this, whether the industry-wise salaries differ or there is no impact of having different industry on the CEO's salary. So before I start answering the question which is there in the caselet, I would like to ask one more question: that do you have any other method? We have understood dummy variable or dummy variable regression method, which can be applied right now. But do you have any other method which can also be used here? Just think. Try to think something logical which you can have, where we can apply such or something, some analysis by which we can, with surety say, yes, the CEO's salary in finance industry is more than the other industries. Do we have any other method or any common sense approach?
So maybe normal descriptive statistics like the mean and the maybe the maximum salary.
This is very good. Tana is correct. What we can do, we can have CEOs, we divide all these CEOs into 4 industries, and in every industry we can find out the mean, and we can look at whether there is a difference in mean or not. This is correct up to the descriptive level, but there is no statistical testing. Suppose I am saying that statistical testing should be there. Why I am insisting upon this, that statistical testing should be there? Unless until it is tested statistically, even if mathematical difference in mean cannot be relied upon, you cannot bank upon that result. Though they, clear-cut 4 mean values are there of CEO salaries of different 4 industries, but despite they may be mathematically different, I cannot say that we can rely upon that. And I would suggest that there should be some statistical test. So my question is, why shall I, or why at all we are insisting on this issue of statistical testing? Anyone can answer this question? After all, you have got the numbers, and numbers differ. Some industry will have higher number. You will straight away conclude that CEOs belonging to that industry will have higher salary. Matter is over. So what is the utility of having some statistical test? Just because we are studying, we are doing MBA, or we are studying statistics or econometrics, so we are saying no, we have to test. Is that the logic or something else?
So is it because we have only sampled a few
And
of
let,
them?
let other people also react to it. I'll get back to you if nobody else responds. Yeah,
So
I
to
want
find
other people
out,
also to chip in. Yes,
to
please go ahead.
find out by what amount the salaries differ, or uh, the relative, um, the relationship between them, something like that.
No, that job has been done by calculating the mean. My question is very simple. Why am I insisting upon using some statistical test to verify? What is the sanctity of having the statistical test? Why at all statistics should be applied?
Sir, one of the reason is like if we just do the mean, we'll just know if it is greater than the mean or lesser than the mean. But then we cannot say that it is because of the industry, like how much it is dependent on industry, or there are any other factors which can affect. So
No, but
maybe that.
number will speak for itself. Number CEO mean salary of a particular industry is higher than the CEO salary mean salary of another industry. So what's wrong in concluding that the industry where mean salary is high is giving higher salary to their CEOs? What's wrong in this conclusion?
Sir,
Why insistence upon statistical testing?
the mean is a
Your voice is not clear.
sir the mean.
Yeah. Tell me.
Okay, so the mean is a very skewed data. For example, a few CEOs might have a very high salary, and that tends to affect the mean to a very largely affect the mean of that overall
That's
industry.
okay. That's okay. That you are correct. That mathematical average. So you will suggest that we'll go for median positional average. Will that solve the problem, or still some amount of problem will prevail? When you go for positional average like median, this problem will be sorted out of the extreme values or outliers. We'll have middle item number value as the average salary, and we can still compare median of all the 4 industry, and we can conclude this industry which is having higher median salary is a appropriate better industry, giving more money to their CEOs. So this problem, what you are saying, lopsided average may be skewed, can be sorted out. But I think that my question still remains there. What is the sanctity of having the statistical testing?
So it might be possible that these values are there by chance only. So there might not be a relationship between the industry and the CEO salaries. So just to cross verify that, we would be doing statistical testing.
No, rather the right answer is, if you remember my discussions, I have told you there is 2 type of statistics, or statistics can be divided into 2 parts: descriptive statistics and inferential statistics. Just a second, let me Yeah, I was just showing you there are two types of statistics, descriptive and inferential. What happened in descriptive, whatever we are discussing, that is here. But think why we do inferential statistics, because we have got some data. We have the population, all the salaries of all the industries, and then we have got just one sample. And whatever result we are having, the median also. You can't have people or CEOs, all the CEOs of a particular industry. You have obviously just sample of how many? I mean, we had certain number. So only that many CEOs are with us. 209. 209 is not the whole number. It is obviously a sample. So when you are having some data of a sample and you want to have some idea about the population, you can't do it unless until you go for statistical testing or significance testing. I hope my point is clear to you. So application of inferential statistics is incomplete unless until you have done the statistical testing. Sample cannot be relied upon unless until you have verified with the help of statistical significance whether this result is significantly meaningful or not. Mathematically might be there, no problem. It's a sample data. Sample is not population. Hope I have answered the question.
Yes, sir.
Yes, sir.
So you're clear? Somebody asked why statistics? Tell boss, I'm handling the sample, and sample cannot be as it is used for population or generalized. It cannot be generalized like that. You have to have certain process, and that process is statistical testing. Once you test it, then only you will say yes, my sample result is fit to be applied on population. That is the idea. So that is the answer to my question. Coming back. Let me get the data on the Stata. I said that first of all, I'll be testing. I guess I have got the data. Yes, here. I've told you that the data as you are seeing it here. So I have got salaries, I have got ROE, and as you are finding that salaries again in thousands. So, but despite that, what you are finding that there is a clear-cut difference in the scale. So I would go for calculating the log of salary, and then I'll be running my regression. So I'll generate L salary. Yeah, L salary is equal to log. And here I have got the log of salary as the one new variable as you are finding it here. Can you see on the screen L salary?
Yes, sir.
Yes, sir.
Okay. So
Yes.
now we can run the regression of L salary, and we'll have independent variable ROE, and we'll see the result. What we are finding here, if you look at here, this is the p-value corresponding to the ROE, and which is less than 0.05. Remember the discussion I've told you, we have always have a generic pair of hypothesis. Bj is equal to 0, alternate beta j is not equal to 0. And as we are finding that p value is less than 0.05, null is rejected. This is the generic statement I told to remember all the time. We are going to use it. So keeping that in mind, what we can say, the result p value is less than 0.05. P value is less than 0.05, so null should be rejected. So null of beta is equal to 0 can be rejected, and we are going to accept the alternate that beta is non-zero. So we will conclude that ROE is significantly impacting the salary, and the coefficient is obviously plus. So more the ROE, again this plus minus issue is there. This is plus. So we'll say that higher the ROE, higher the salary. So this part is okay. But now we have a follow-up or further question in this caselet that we have got salaries of 4 industry. So if you look at the Excel itself, you will find that the CEOs of transportation industry would have been given 1 for trans and then 0 for all the other industries. finance industry people or CEOs of finance industry would have given 1 in this variable, which I'm naming as finance. So consumer product, similarly, CEOs of consumer product would have been given 1, and utility also, same thing, CEOs of utility would have been given this dummy variable. So what we have done, we have calculated 4 dummy variable, and I think I have removed the function here, otherwise I can use, I had one more column where different numbers or names would have been given to different industry, and from there I have converted, I have made these dummy variables. So we have discussed in last class how to make use of Excel as well as a Stata to calculate or to find out the dummy variable. So that I'm not repeating. I'm taking straight away that this is the dummy variable for transportation industry. This is for finance, this is consumer product, and this is for utility dummy variable. Utility dummy variable for having 1 value for CEOs of utility industry and 0 for all the other industry. As you can see, if I scroll it down, you will find it. So if you remember last time we were talking that the role of dummy variable is not limited to a case where we have only 2, as we had in last caselet when we were talking about cars. We had 2 values of the road test score, high and low. And what we did, we gave 1 to low and high, low to 0 and 1 to high, and we have got this dummy variable and we have made use of it. It was very obvious that we had 2 dichotomous, a variable having 2 options. Right now, if I look at what I'm doing when I'm talking about the CEO salary caselet, so practically if I call it the variable which is talking about the industry, so I can call that variable as categorical variable or non-metric variable. And if I look at number of categories, then this is 4. And from here, what I have done, I have made 4 dummy variables. Dummy variable 1, dummy variable 2, dummy variable 3, and dummy variable 4. One is for, I think, one is for transportation. Second was for finance. Third is for consumer product. And fourth is for utility. So the point here I'm trying to bring home is that application of dummy variable is not limited to only those cases where you have got 2 options. Here we have got 4 options in the category. But this is a fact that dummy variable is applied only for having the situation of 2. So what we have done, we have converted artificially categorical variable which is having 4 category, we have made 4 dummy variable. So this having 1 for those who have the, CEOs having the are in the transportation industry and 0 for other. Likewise, I would have made 3 other dummy variable. So this is what I have done. So now what we can do, we can run regression of log of salary with all the 4 dummy variable 1 by 1. And then I will put all of them together, and I may also put ROE as the independent variable, and I can run the regression. So all these situations will give me different results, and they are going to serve different purposes. So first of all, I'll be using the industry-wise dummy variable 1 by 1, and then all of them will be put together, so results will be different. So let's start with the individual situations. So here, let's say I'm taking the dummy variable transportation, and I'm just going to run the regression. So if I look at the shape of the regression, then regression is going to be y beta 0 plus beta 1 and dummy variable. This dummy variable will be for dv1 to dv4. And what we are going to do, as we run this regression, we will look at whether this is significant or not. This is something what we are going to answer. Significance means the null of beta 0 is equal to 0 should be rejected. And if this null of beta j0 is rejected, we will say that this beta 1, I can say that it is not j, rather it is 1. I'll say that beta 1 is significant. So significant means the coefficient is non-zero, means null should be rejected. So if I run this regression using a particular dummy variable and beta 1 comes out to be significant, or it can reject the null, I will say that CEO salary for dummy variable 1 or the industry which this is signifying is having different salary than the other industry CEO salary. So significance of this will decide. Suppose this is for transportation industry dummy variable and this comes out to be significant, then my interpretation will be that CEOs of transportation industry are paid differently. Whether high or low, that will be decided later on. That we can understand by looking at the mean value. Right now, what is going to be decided, whether transportation industry CEOs are paid differently than other industries or not. That is the only purpose. If you look at the construction of dummy variable, 1 for transportation industry CEO, 0 for other. So only difference is tested. Which is high, which is low, that can also be discussed by looking at the data. But the basic idea of using the dummy variable is to find out whether the salaries of this particular dummy variable, the industry which is being signified by this dummy variable is different or not. So we'll come back to this regression. This is the setup. As I run the regression, transportation dummy variable is here. I'm looking at the p-value and what I'm finding, p-value is more than 0.05. So when p-value is more than 0.5, we have discussed p-value should be 0.05, only then null is rejected. P-value is not less than 0.05, rather it is more than 0.05. The conclusion is null cannot be rejected. So here what is happening? This rejection, what we were saying, is not happening. Rather, we are bound, we can't reject this. So we have to accept. We have to accept that beta 1 is equal to 0 or the dummy variable related with this transportation industry is having a coefficient which is not significant. Significance is not there, not significant. So conclusion will be CEOs of transportation industry are not paid differently. They are paid like any other industry. So there is no difference if somebody, one CEO belongs to transportation industry. This is the output of my result. Any question if you have?
Sir, to run this particular regression for one variable, what are the data we are taking? Can you please tell that?
No, we have just taken one dummy variable. Look at this variable. This is dummy variable. It is giving 1 if the CEO is of transportation industry. And if the CEO is of any other industry, he has been given 0. Got it?
That, sir, I understood. Like for running that regression, so we are taking salary and the trans column to run the regression, for which we are getting
Trans
P.
is nothing but one dummy variable. Trans is nothing but a dummy variable.
Yeah, just
The
any
dummy
variable and the salary one by one.
I have run. Yeah, this is what I have run.
Okay.
Trans, I have taken trans. This is just a dummy variable. I've got 4 dummy variables. So I'm making use of them. 4 dummy variables.
Sir, I got that. Sir, just one other question. So in that column of the dummy variable, that 1 and 0 that we are putting, how are we doing that, or is it given from
No,
before?
I told you last class I have discussed now. We can use if function, or we can use a command in this. The command was gen. You write the name of dummy variable dv is equal to, put the bracket and write down the condition here, whatever condition. I mean, as per the availability of the variables here. Right now we do not have that variable. Let's say there would have been one variable where one means transportation. So you would have written, let's say name of that variable is var is equal to shown written in starter by 2 equal to 1, and that's it. It means the variable wherever it is 1, that will be having a new dummy variable where wherever var is 1 will be 1 dummy variable value, and wherever var is not equal to 1, dummy variable will be 0. So this is the way by which you can create dummy variable in Stata. This is what we have discussed in the last class.
So basically, we have a complete column wherein we know case the particular CEO is from which industry, and according to that, we have created a dummy variable.
Absolutely, absolutely. So this exercise is not that important. You know, what is the exercise? We have got data, so that data can be easily converted into dummy variables. So the purpose of dummy is clear, and how it can be created, that is also clear. That's it. Now what we are doing, we are trying to understand the use of dummy variable in the regression. So creation of dummy variable, I think it's easy. I've repeated it 2 times. You want me to again discuss how to create dummy variable?
No, sir, we remember less than medium, then we'll take 0 and greater.
No, that is the condition, you know. You
Yes.
can't generalize. In the third situation, you will have your own condition.
Yeah, there will be a condition according to
Condition.
which
Accordingly,
one,
you will
then
give
we will
command in.
create the
Yeah,
dummy
yeah.
variable.
Yes, yes, yes. Anyone else, anybody else has got any problem in creating dummy? You tell me, I'll share, I'll discuss again. Okay, so I'm assuming no problem. So here is the result. So we have discussed this result of dummy variable of transportation industry CEOs, and we have got insignificant beta. So we are concluding that there is no impact of transportation. We can say that transportation, which we have written, transportation is not coming significant. And then we are going to test the second is finance, and third will be testing the consumer durable, and fourth we'll be discussing utility. And we'll see whether the significance is there or not. When it is not significant, then we'll say that the transportation industry CEOs are not getting anything different. They are like any other CEO. There's no difference by being in the transportation industry in terms of salary. When I say not different, means either ways. Neither the CEOs of transportation industry are paid more than the normal or paid less than the normal. So they are paid like any other CEO of any other industry. That is the interpretation when we say it is not significant. Had it been significant, then we have to again look at the coefficients, the value of coefficient, sign of the coefficient, or mean value. And then we would be able to tell whether when it is significant, then only we'll say that the CAs of a particular industry are paid more or less. So that we'll see. Right now we will surely have a case where we will be having dummy variable which is significant, and then we'll talk about how to interpret the result. But as long as it is insignificant, interpretation is very clear. The CEOs of transportation industries are not paid differently. And when I say not paid differently, I'm talking either ways, means neither more nor less. It's also very important, not less. It's not that all the time we talk about more. Shall I move on?
Sir, can you please repeat that part? I just lost you in between.
What?
Sir, significance part.
What? Please come again.
Sir, significance part. I just lost you in between that, sir.
What I'm saying, as I have just run the this this regression I have run, where trans is nothing but the dummy variable of the transportation industry CEO. As I run this regression, what is happening? This dummy variable is having a coefficient which is minus, as you are finding it here. Why it is coming minus right now? Okay, it is minus all the way. Right. So it is coming minus, but just because this is not significant, the coefficient of transportation industry CEO dummy variable is not significant. So what we are concluding that the CEOs who are in the transportation industry, they are not paid salaries differently than the normal salary. They are paid like any other person. And when we are making this statement, what we are saying that CEOs or transportation industry, they are neither paid more, and equally I'm saying they are not paid less. They are just indifferent to the industry. So being in the transportation industry, there is no impact on the salary. That is the interpretation.
Yes, I got it. Thanks.
Anyone else? Yeah, please tell me. Okay, so I'm running the next regression using the, if you remember, I told you that I'll be running all 4 dummy variables individually. So right now I'm going to take the second dummy variable, which is of CEOs of the financial sector. So those CEOs who are in the financial sector, in front of them, the finance dummy variable would have been given a value of 1 and 0 for all the other CEOs. CEOs of any other industry are given 0 and 1 to financial sector CEOs. So these are the CEOs, the salaries belonging to CEOs who are in the finance industry. So this dummy variable finance is for CEOs of the financial sector. So as I run this regression, may I run? And what I'm again finding here, that the p-value linked with this dummy variable is coming out to be insignificant. I'm straight away talking insignificant because p-value is less than 0.05. When I say p-value is less than 0.05, sorry, more than, I'm sorry, it is more than. P-value is more than 0.05, so null cannot be rejected. So null is rejected only when the p-value is less than 0.05. If it is not less than, then it means null cannot be rejected. So null of 0 cannot be rejected. So when null of 0 cannot be rejected, we say that coefficient is insignificant. I repeat this language. When p-value is not less than 0.05, null of coefficient is equal to 0 cannot be rejected. In that case, we'll say that this coefficient or the corresponding variable is insignificant. So right now my conclusion is, just by looking at this regression, the coefficient linked with finance dummy variable is having a p-value which is not less than 0.05. 0.146 is not less than 0.05. So null of beta is equal to 0 cannot be rejected. It has to be accepted. So we'll say that there is no impact on the salary by somebody, by a CEO who's in the finance industry. So the CEOs who are in the finance industry, they do not have different salary than the normal. They have just usual salary like anyone else. They do not have neither high nor less salary just because they are in the financial sector. I hope the point is clear. Same result, only the dummy variable is different. Earlier we had earlier we had transportation, and right now we are having the finance, and now we'll be testing for consumer product, and then we'll be testing for utility. So these first two items have given the same result. So whether it is transportation or finance, I've got the same result for CEOs of these two industries. Going back to running one more regression, I'll be having consumer product. As I run the regression, here we are getting something different than the previous two dummy variables. Look at the p-value linked with the consumer product dummy variable, which is less than 0.05. So what we are concluding, if we again look at the results, p-value right now, p-value is less than 0.05. So we'll say null is rejected. So null of coefficient is equal to 0 is rejected. So non-zero null is, non-zero coefficient value is accepted. So we can also say that coefficient is significant. When coefficient is significant, so our conclusion will be that those CEOs who are in the consumer product industry, they are paid differently. This is clear. Are you with me? This idea is clear just because the dummy variable of consumer product CEOs are significant. That CEOs who are working with consumer product industry, their salaries are different from the others. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
If I just complete this table, again, this was insignificant finance. So there is no impact of on the salary by the CEOs who are in the finance industry. But here the case is different. For consumer durable, the impact is significant. Means if somebody is in consumer durable, then salaries are going to be different. But now we'll also look at whether it is positively associated or negatively. What we are finding that coefficient is positive means if somebody is in the consumer product industry, some CEO, then the salary will be incremental to this. This is the constant value. I'll explain to you with the help of equation which I was using. Yeah, this is the equation. So what is happening if you look at, I'll write it again here. Y is equal to beta 0 plus beta 1 x. Right now I've got dummy variable. So I'll call it dummy variable. So what is happening if beta 1 is equal to 0, which is the case of insignificance. So what will happen that y will be beta 0, means salary will be equal to a constant, which is across the board. There is no difference because somebody is there in a particular industry. But if beta 1 is not equal to 0, that is the situation of significance. So what will happen? The y, which is nothing but the salary, will be beta 0, and obviously dummy variable value, if beta 1 is non-zero, will be 1 for somebody who's in that particular industry. Right now it is in consumer durable industry. So salary will be a combination of beta 0 plus beta 1. So beta 1 is the factor which is either getting added or getting subtracted as per the sign of beta 1. My point is clear? So here the sign of beta 1 is important when beta 1 is significant. So right now, as we are running this regression with the consumer product dummy variable is having beta value which is significant because p value is less than 0.05. And if you look at this, what we are finding, this is positive. So this is going to be added. It means if somebody is working in consumer product industry, then that CEO will be getting 0.275 more salary than the normal salary. Is this logic clear?
Yes, sir.
So by after significance, the next thing which we see is the value of coefficient of the dummy variable. There are two possibilities. Either it can be plus or minus. If it is plus, we'll say that the impact of dummy variable is positive. And if it is negative, we'll say impact of that dummy variable is negative from the normal, from the general idea. Open question if you have, anyone of you. So coming back, running the last regression. Last regression is for the fourth industry, which is utility.
So, interrupt you.
Please tell me.
So, please repeat that coefficient part, the last part you explained right now.
What I said last part, that this is the thing which I tried to explain. If beta 1 is insignificant, then there is no impact of beta 1 because the dummy variable will not be having any role, because this beta 1 will be equal to 0. So just because beta 1 is statistically 0, so why will be beta 0, which is nothing but the general, normal, generic case. But if beta 1 is non-zero or beta 1 is significant, then what will happen? Beta 1 will be there, and dummy variable 1 will be when somebody is in that particular industry for which that beta 1 was calculated. So like here in consumer durable, for consumer durable dummy variable, if somebody is in the consumer durable, then dummy variable for that particular CO will be 1. So that will be added. So why the salary will be beta 0, which is general, plus beta 1. But again, if I take the somebody from non-consumer durable industry, so corresponding dummy variable value for that particular CO will be 0. So that will remain beta 0. We have to look that separately. As so far we have seen, this is the case. Accordingly, we'll be talking about whether somebody belongs to finance, transportation, or will see to the CEO in the utility industry. But this is what we are sure, that if somebody is in the consumer durable industry, then beta 1, beta, the corresponding beta is significant. So that much beta is, or that much value is going to be added in the generic case. And corresponding dummy variable value will obviously be 1 because somebody or the CEO will be in the consumer durable industry. Right?
Right, sir. Thank you, sir.
Running the next regression. Feel free in asking. I'm not in a hurry. I have enough time, don't you worry. I'm slow. Okay, so next regression. If you look at what I have done, I have run the regression for transportation dummy variable, for finance, for consumer product. Right now, I'm going to run for the last dummy variable which we have created in data, that is CEOs of utility industry. And as I run this regression, we'll get to know by looking at the coefficient whether the CEOs and are paid differently than the normal or not. What we are finding, this is strongly significant because p-value is 0.000. It means p-value is less than 0.05. Null of coefficient equal to 0 is rejected. So whenever we talk about in terms of coefficients in regression analysis, if p-value is less than 0.05, we use this term that this coefficient is significant. And smaller the value of p-value, we'll say strongly significant. So right now, just because it is 0.0, I mean, right before that it was not 0.0, 0.001. So between 0.001 and 0.00, this is more significant, strongly significant. So one thing is sure, that the CEOs of utility industry is also paid differently from the normal. But as we look at this sign, what we are finding, last discussion was we had when we were talking about consumer product, then what we had coefficient which was positive, significant and positive. So we said that the CEOs in consumer product industry are paid more than the normal. But right now, as I have run the regression of utility, what we are finding that it is significant perfectly well. So this much is okay if I have to elaborate that CEOs in the utility industry are paid differently. But how much? For that, I have to look at first of all the sign. Sign is negative. So one thing is clear by looking at the significant correlation coefficient of utility dummy variable, that those who are working in utility industry, they are paid less than the normal. If I have to, show here like this, the way I was showing it here, it is significant, perfectly all right. But what we are finding here is that here the sign is negative. Sign is negative. So what is going to happen? This is not plus, rather this is minus. So in a way we can say that Y for utility will be less than Y for just normal. So CEOs working in utility industry will be paid less than anyone else. So on an average, CEOs of utility industry are paid less than the normal CEOs. That is the interpretation. And both the conclusions that utility industry CEO are paid differently can be concluded by looking at the significance of this coefficient. And then by looking at the sign, we can conclude whether the CEOs of utility industry are paid more or less. So right now what we have done, we have practically tested all the four industry and we have concluded. And what we can say that this is also significant. So impact is yes, but what we are finding that this impact is plus, but this impact is minus. Yes.
Yes, sir.
Anyone else? So what we have done with this exercise that we have used dummy variable. We have a categorical variable that CEOs are different salary having 4 categories. From that 4 category we have converted, though I have not done right now, but we have got the data from that source only. And we have got dummy variable of 4 industry CEOs and we have tested individually. And what we are finding that CEOs of consumer product, consumer durable and utility industry are paid differently and transportation and finance are paid usually. And when we compare further these two, what we are finding that consumer durable CEOs are paid more and utility CEOs are paid less. That is what the final conclusion of this whole exercise so far. But if you remember, I've discussed that we need to talk about a situation where we are going to take all 4 and maybe ROE together. So we'll do it one by one. Transportation, and we'll take finance, then we'll take consumer product, then we'll take utility. Now here, one very important thing. All of you please pay attention. Whenever you are having a categorical variable, or in this example 4 categories, and you have made 4 dummy variable, then as a matter of rule, if you have to run you want to test all 4 together, then there are 2 options. Either you give one situation of no constant term, this constant term. Whenever we run a regression, we get a constant term. So somebody asked that why don't we worry for the significance of constant term? Because constant terms are essential for having a regression a meaningful thing. I mean, if you remember, I talked about the blue OLS estimator should be blue. So the biasness, unbiasedness, consistency, significance, all those things are there, are quite helpful when we are having the constant. If we don't have constant, then a few assumptions will not hold true of OLS. So that's why constants are necessary. That was a digression. So if we stick to the idea, so here point is, if I am having right now 4 dummy variable, because my data is having 4 categories, and if I want to test all 4 together, then that would be a problematic thing. What I need to do, either I knock out this constant term, which is not recommended, or I test minus n minus one number of dummy variables. I repeat, whatever is the number of dummy variables you have in a system, all of them cannot be tested together. If you have m number of dummy variables, then as a matter of rule, you only run m minus one dummy variable together, and you will use constant, which is there in the system, as the mth dummy variable. So we have taken n minus one dummy variables, and constant will be treated as the remaining dummy variable. So altogether there are m dummy variable, but the construction is different. If we do not follow this rule, means if we take constant also and if we take m dummy variable, then the matrices which are made to solve the OLS will not run. You will have singular matrix error. So you won't be able to, whether you do it manually or computer based, you won't get result. So we call it dummy variable trap. So if in a system you have m number of dummy variables, and you should not knock out constant term because you want to have your regression a meaningful regression. In that case, out of m dummy variables, as a matter of rule, only run m minus one together and treat constant term like beta 0 as the in the place of missed out dummy variable. So this rule should always be kept in mind. Whenever we are running dummy variable for more than one categories, we have to always take care of this, that all the dummy variables should not be put in the system together, rather minus one, and for the practical purpose, constant will be considered for the missed out dummy variable. So that is one very important precaution. If you ignore what I have just said, then you won't be able to run dummy variable, and you will have always. So this is something which you have to remember all the time whenever you are going to apply dummy variable. All the dummy variable in the system should not be run together. Rather, m minus one dummy variable should be run together. Point is clear?
Yes,
Yes,
sir.
sir.
So here I'll not run all, I'll run any of one, any out of these four I can leave anyone. Whichever one I am leaving, I'll consider that missed out dummy variable will be treated with the help of constant. I'll show to you how it is done. But anyone I can leave out. It's not that I have to leave out first or last. No, there is no such rule. Anyone. If you have four, then all four cannot be run together. Rather, I have to use only three dummy variables. So fourth have to be left out. Which one is fourth? There's no rule. Right? So if I run this, I've got this. Look at here. How to interpret, that is important, that I'll show to you. If I have to interpret this result, then what happened? I will first of all look at the significance. All are coming significant. Still, we won't pay attention to the constant. All the three dummy variables are significant. So we can say collectively also, so robustness is there in the result. When you in the multiple situation you get the same result, we say that result is robust. Means the result remains same when you have some fluctuation in the analysis. So we'll say that result that, but one thing is there, transportation was not significant earlier. Right now it is. So transportation and finance, but right now what we are having, I mean, individually when we run, we had consumer product, but these two items are coming additionally. This is because the mutual impact of finance, mutual impact of these three are creating a situation which we have to let it be like that. We can't do anything, and we have to interpret the results accordingly. So what we will conclude here is that as we run all together, what we are finding that all the three are showing significant, but this result is inferior to the result when we have run individually dummy variable. So that result is more stronger if I have to say that out of these four industry, which industry people are paid differently, then this is a strong result. Right now, whatever I'm doing, I'm trying to compare that which one is paid by the other how much. Right now, we haven't done. What we have done, we have only understood whether the people, CEOs of consumer durable industry, they are paid more than the other people. Yes, and whether they are paid more or less, that we have understood by looking at the sign. But when we are running this regression, what we can at least tell that between these two industry, the people of consumer product industry are paid how much more, that we can tell some number with the help of this joint regression analysis, which cannot be done earlier. But the issue that the significance, these two are insignificant, will prevail. That will not be nullified. That will always remain there, because individually we have tested and the results have come like this. So we'll stick to it. But if I want to know the difference in CEO's salary of these four, and that too not by just calculating the mean, rather statistically, then we have to rely upon the results which are just going to come. I'll show you, I'll tell you the numbers also, how to interpret this result. This point is clear. Why to run all four together? Rather three, four I can't. I have to run three. Fourth, I'm assuming that I have the constant value, which will work for the fourth missed out dummy variable. So, anyone has any doubt? If it is not admissible, you have some lack of understanding. So, look at here. If I have to define it, so constant will be, this is the average value. This is the average value, and this is for people of utility industry. So we'll say that utility industry people will be paid a salary of Y, which is nothing but L salary. So their average value is 6.511. 6.511. We have to take the EXP, I mean the exponential value, and then we can calculate the actual value, the value which we are using in the table. Now look at the interpretation. Look at the consumer product. What is happening? What you are finding that all four, utility was negative. We remember utility was negative. As we have shown that it was negative. But right now we have removed utility. So we are using utility as the base, because utility dummy variable we have left out. So what we are saying that this result is, this is for utility CEOs. This is for rather, let me put it here, utility CEO salary in log form will be 6.511. As we move to consumer product, I can say 6.511 plus whatever is the value of the coefficient. This is nothing but 0.6353, 0.6353, and this is 468 and no. This is 6.6863 is the salary of consumer product CEO. Likewise, I can calculate for finance also. So base will remain same. I have to add, or if there is minus, we are supposed to subtract 0.5468. 0.5468. So this value is equal to 6.87875, and this so it will be 7.0578. And similarly, I can calculate for trans. So what I'm doing, I'm just adding the coefficient value. Coefficients are significant, so there's no problem in adding with the constant, and I'm getting the salary which transportation industry CEO is supposed to get. 6.5110 plus The value is 4259.4259. So value is equal to 963 and 9.6.9369. So here I can clearly tell that difference between utility and consumer product is this, difference between utility and finance is this, and usually also you can find out what is the difference. So these numbers, so ideas have been converted into numbers. When we say that people, CEOs in a particular industry are paid more, then using dummy variable, you can give some mathematical number that these many ₹1,000 are more, $1,000 are paid more to the people, those who are working in a particular industry. So this is one of the applications. Questions? No questions? Either none of you have understood, all of you have understood everything.
So could you just show the output that we wrote? Okay.
So
Sir,
start output.
no, that one, sir. Got it. So it will be 6.511 plus
6.55 divides the
that
constant
coefficient
value.
of individual.
This will
Okay,
remain same, and individually same logic is same. The way we were explaining, this is the logic, this is the logic. So beta 0 is same. For every dummy variable, we are adding its beta 1 value in beta 0, and we are coming out with the results.
Sure. Thank you.
So
Anyone else? Yeah,
uh,
please tell me.
if you would have dropped some other things like finance or something, would the
No,
answer
no. Answers will not change. Everything will remain same. Significant may change, but other things will not change. Like I'll do it for you. Like we'll drop the transportation, we'll have utility. I'll run the regression. Look at utility is giving you minus. If you just roughly calculate for one, this constant is there. And utility value was how much? Utility value was 6.511. And that was with a few rounding also. So if I just calculate value, you can also use your calculator to find out 6.9371 minus 0.4259. So it is coming out to be same 6.511. Same values coming.
Okay, sir. Thank you.
So that will not impact anything. That which dummy variable you would have dropped, that will remain same. Significance may differ because as you are finding, significance may differ. So as I told you that individual regressions are more important, far more outweigh. So we'll stick to it. When we are doing collective, it is the purpose is to find out the mutual understanding that how much they are industry wise or category wise of the categorical variable they are paid or they are having different values. That is the purpose.
Sir, so the data that we'll be getting here, so it should corroborate with the single regression that we run. For example, if we are getting utility 6.511 and in the single we were getting it was less than the
No,
normal.
single was meant only for the
Not the
purpose.
data exact.
They are having significant impact on salary, number one. An impact if it is significant, whether it is positively impacting or negatively. These are the two purposes of using individual dummy variable regression.
Yes, sir, that I understood. I'm asking, so that utility, it is significant and it is less than the standard.
Where you are talking about collective?
No, sir, in the single variable, we got that utility is significantly impacted, like it will be different and it will be less than the
it will
normal.
be negatively impacted.
So,
Yeah.
so in the regression where we are multiple regression, so in that also we will get the similar kind of data,
Similar
right?
kind of, but I can't claim that exactly same because
Yeah,
if you remember,
exactly.
when I
But
talked
then,
about multicollinearity, let me complete this. So in multicollinearity, I said that mutual association is not a problem. High level of association is a problem. That's why we said that multicollinearity is a problem only when the correlation coefficient value is significant and more than 0.8. So point here I'm trying to prove is that smaller association is taken for granted and that is not supposed to impact the regression result adversely. But impact will be there. And that's why the results what you are finding, the finance and consumer product and utility was significant. Right now it is matching, but the previous regression when we run, what we have found that all were transportation and finance individually were not significant. Right now it is significant because of the mutual association of dummy variable. This is just I just wanted to tell. You were saying something. Please complete what you wanted to say.
no, sir, I was saying the same thing.
Point is clear.
Yes, thank you.
Anyone else?
Sir, I had a question regarding the log change that we do. So in our data, we have found that many variables we get as negative. Like
Okay.
some are positive, some are negative, and when we are doing the log natural
Okay.
to convert that, so log doesn't take that value. So we are supposed to leave that as.
I don't think so. The impact is studied that we can say. So
Sir, what I did was I took the
when we have to
modulus of
calculate the value, we have to take exponential to the power. So exponential power negative it takes. Values will be less. That's it.
No, sir. Like for a column, we have when we have different values, like one are three digits.
That is a
That
problem. When we have negative values in the and we can't take log. This is what you are saying.
yes, sir.
In that case, one of the solution can be you calculate the rate. Let's say you have yesterday somebody was talking. Let's say you have got profits. Profits are negative loss. Then take the rate. When you take rate and when you are having loss, you will have a negative rate. Then rate means it will be in point something, 0.12, 0.35, 0.03, plus or minus doesn't matter. Then you add plus one. Now you are having something which is all positive. But first of all, when you take rate, then there is no need to take the log because then the rate will be scaled up already. Rate will be in decimals and you are having some two-digit values, no problem. You can run the regression. So again, as per the case, solution is there. So solution which I told was for profit having losses in the data. So I suggested that convert that into rate and you run the regression. So solution will be case to case. But what you are saying is there, negative value log cannot be calculated.
Okay, thank you, sir.
If you calculate geometric mean for that matter, geometric mean you would have done. So geometric mean when we calculate, then suppose you have values which are plus and minus. GM cannot be calculated geometric mean. So what is the solution there? We add, let's say there are rates. Rates are in plus and minus. Suppose you have calculated the weekly growth rate of stock price. Then you will have maybe 1%, 2% plus or minus. So all are in points. You add by one. So by the time you add it by one, what will happen? Values will be 1 point something or 0.9597, something like that. Then you have all the positive value. Calculate geometric mean. Whatever GM come, put -1 and you will have a positive value. So GM is also calculated and problem of negativity is also solved. So point here is the negative issues are handled as per the case.
Okay, thank you, sir.
Anyone else?
Sir, I had a question.
Please tell me.
So, sir, while doing the reset test on eViews, Sir, there is a certain variable called likelihood ratio, which I see along with the t statistic. And sir, that value is not like fixing the criterion that my model follows. That it is getting a value less than 0.05. But the other two values are greater than 0.05, sir. How should I like go? One,
Take the
what is
first
likelihood
value.
ratio?
Take the first value which we have discussed.
Right, sir. Right.
That is good enough.
So t statistic value is greater than 0.05, sir. It is 0.1047 that I'm getting.
That's okay, no problem. It means your model does not have a specification problem.
But sir, what does likelihood ratio mean, sir, exactly? Like
log likelihood ratio, that depends which test we are doing, because test interpretation is based upon the null. So
Right.
I can't generalize, but log likelihood tests are done at different situation. That depends. So it's also one of the tools like t-test, like f-test.
Right.
We are using t and f both. When we are, I'll give you a simple example. Right now, when we are running, these are t-test, and this is f-test. So when you are testing the model, you are making use of f-test. And when you are talking about the significance of individual coefficients, you are making use of t-test. So likewise, a couple of times when we are running the regression for heteroscarcity test, we are making use of chi-square test. You understood?
Right. I got your point. I got your point.
Basic idea is the concept of pair of hypothesis should be clear. And what is a test? And then accordingly look at the p-value and give the judgment about whether the null is accepted or rejected, and accordingly you can go ahead.
Sure, sir. Thank you.
So we will, somebody saying, please.
Hello, sir. Yeah, this is Nishant here. Okay, so when I was doing the assignment, that time I ran the regression test, and one of the variables, its p-value is 0.000. So that's not an issue, right? It means that the variable is significant, just that it's extreme.
Correct.
And even in the f test, I'm observing it's 0.000. That's also fine, right?
Perfect. No, all are significant.
Okay, thank you, sir.
Sir, I had another question to ask. Sir, what is an optimal adjusted R value, sir? What is an optimal value for that?
R value, R square.
Yes, sir. The R square method. What is an optimal value, sir? What is the range that we're looking at?
Actually, that's a very big question. Very big in the sense that depends what we are testing.
Right, sir.
And at times that depends on data to data, the components which you are testing. Let's say there's a simple logic set that when you are running the behavioral studies, data from the behavioral studies, so even 30-40% of R square, adjusted R square, is supposed to be very great. When you are running normal quantitative data, let's say secondary data like GDP, GNP and all, then 60-70% may supposed to be very good. So it is wrong to say what is the correct value. Higher is always better. There is no doubt about it. What happens? Suppose you are doing a study on impact of different stock indices on Indian stock index. Let's say on Sensex, you are studying the couple of indices and you are running the R square. Suppose you have run simple regression, multiple regression using time series data. And let's say you have got a R square value of 65%. Then whether that is acceptable or not can only be decided by looking at some previous work. Look at some previous studies which are done on the association of stock index of the other indices. And then you will find whether they are having either significantly means in a normal way I'm saying, let's say those are coming out to be in the range of 80s and yours is 65. Then somewhere or the other you will feel that something is wrong. So you should have a proper justification. Justification like you can say the market which you are studying is entirely different due to this point. And if it is not there, then you have to recheck your data, recheck your method, something you might have got wrong. Because the acceptable and majority of the people have got R square value which is higher in the bracket of 80 plus. and you're getting 65. So something may be wrong. So this is very subjective. And again, as per the situation, we'll say that this is the right R square. But higher is always better. What happened?
Understood,
Yes.
sir. Understood. Yeah, thank you.
No, any other thing? I'm not finding you convinced. Tell me something if you have anything.
I got your point that it will depend on a case-to-case basis, but for the
Case to
situation
case,
that
industry to industry, data to data. So no hard and
right,
fast
right.
rule. You won't get anywhere. Even if you try out, you won't get.
Sure, sir.
So I have one more caselet here. I'll at least show you the data, and you can, if you are interested, you can run on your own. Just something is wrong here. Something has gone wrong on my browser, I guess.
Sir, I had a
Visible?
doubt.
Yeah. Tell me.
Sir,
Tell me something is wrong.
yeah, sir, while doing the assignment, sir, we determine that a variable is significant or not depending upon the p-value. If it is less than 0.05, then it is significant. So, but there's one more condition that if or else we can also look at the t stat values. If they are greater than 1.96 or 2, so it is said to be significant as well.
No, I'll suggest to you that don't look at t value. What happened that t value, the critical t value depends on the degrees of freedom. Z test, which is meant for very high number of samples. So practically Z test is not there in the reality because you never know the population standard deviation. So unless until you know population standard deviation, you can't talk about Z test. So t test, so critical values 1.96 plus minus is not applicable. But roughly what we say, if I have to follow rule of thumb, then if the value of t value is more than 2, we usually say it is significant. But again, with certainty, you have to look at the degrees of freedom also. So best is look at p value. When you do not have p value, then only you venture into these areas. When you have p value, use it. What's wrong in this?
Sir, I've come across one problem that my t-stat value is greater than 2, whereas my p-value is also greater than 0.05.
You
So
please
what shall I
understand what
consider
I'm saying.
in that
Listen,
case?
listen. P value and t values are not different. Both are same thing. T value and p value is calculated on t value. Right now, my system is not supporting. Otherwise, let me see if it works. I'll show you. So please understand when I say p value, this is the sampling distribution, and here I have got the critical values. So if I'm talking about two-tailed test, so this is 2.5% and this is 2.5%. So what happened? This is the 1.96 if the n is too large, and this is 1.96. Are you with me? So what happened? This value, what you are saying, that depends on the value of n. So this may be, little more here, little more here. Number one. And let's say when we say p value, so p value is, let's say we are on the right tail, and here is your calculated value. So if I have to define p-value is nothing but in this case, p-value in this case will be, if it is here, so from plus infinity, whatever area is between this curve and this is 1. So say the total area from, because these are asymptotic, meeting at the infinity. So plus infinity till that point, just because this is up to 2.5% from plus infinity, so it will be quite less than 0.25. Let's say it is 1%. P-value will be multiplied by 2, so it is 2%. So this is p-value. So p-value 2%, or you call it 0.02, which is less than 0.05. So there is no fight at all. P-value is 100% reflection of your calculated t-value when you are saying. So this is the t-value which you have got, your t-value. So what happened when your t-value is more than this? You know what you say, that t-value is more than 0.1.9. Let's say here it is coming out to be 2.10. And then you are saying, sir, there is a problem. Your t-value is this, but p-value is giving me 0.05. It means there is no fight. What is happening? This problem which you are finding is because your distribution is not Z distribution, rather it is T distribution. So both are perfectly in sync. If you are getting this situation, that this is the critical value as per the T of your degree of freedom, and it means your value, your estimated value or your calculated value must be here. So T value might be any number, doesn't matter. It may be 2 point something. That's not important. Important is if P value is nothing but from plus infinity till that point, and just because it is crossing the critical value, so it will be more than, let's say, 0.2.6 into 2. This is 5.2% or 0.052. So 0.052 is not less than 0.05. So this is the problem. So your point is here. So whether you are looking at T or P, both are in perfect sync. The rule of 2 or 1.96 can't be applicable because that rule is applied only for very large sample. For Z distribution, for T distribution, that critical value we can calculate. In Excel, I have calculated when I was giving you range T, I, and V, put the probability, you will start getting value of T, critical value, or corresponding P value. Are you with me?
Yes, sir.
So 1.96 is for Z distribution, or when in T, because T test is a particular case of Z, when you do not know the population standard deviation, when the value of n is very large, in T distribution also critical value will be plus minus 1.96. But in reality, whether you are getting T value which is 2, but if P value is more than 0.05, so this is the case which I have shown you here, it would be. So T value may be 2 because of the T distribution. But if the the P value is more than, I mean, on this side, on the acceptance reason, not on the rejection reason. So you will always get P value which is not less than 0.05, but more than 0.05.
Okay, sir. Sir, in that case, the variable is said to be insignificant, right? Even though your t value is more than 2,
If
and
that is the case, I suggested go for marginal significance up to 0.65, 0.6, 0.06. We say that you consider it as marginally significant, but report it that it is marginally significant.
Okay, sir.
I've given you the way out, marginal significance, which is used by practitioners.
Right, sir.
Hello, sir. Manisha here.
Yeah, tell me.
Sir, in the assignment part, in the heteroscedasticity part, p values should be greater than 0.05, right? But in my assignment, I found that it is less than 0.05.
So it should be less than 0.05, no? Then only the whatever you are testing, you are talking about heteroscedasticity. In case of heteroscedasticity, the null is there is no heteroscedasticity. So if your value is more than less than 0.05, it means your null of no heteroscedasticity is accepted. So if
it means there is a problem of heteroscedasticity.
Problem of heteroscedasticity, yeah. But if it is marginal, you can ignore, you report it and say it is marginally significant, so I'll consider it as less significant, less severe. But if it is clear-cut, significant means, let's say 0.000 is their p-value of heteroscedasticity test, then you'll say that yes, problem is severe, can't be ignored. It is not a marginal case.
Okay, sure. Thank you.
Okay, so we'll close today. We have practically finished dummy variable regression. Next class will be on ARIMA. We are most probably meeting on Wednesday. Wednesday means 3rd. And we'll take the discussion to ARIMA. So ARIMA, VAR, I think next week we will try to touch these. ARIMA is univariate, VAR is multivariate. So that would be very interesting discussions. We'll resume on Wednesday. And I hope all of you would be submitting your assignment. Before class, I found 3-4 people would have submitted. Okay, so shall we close?
Sir, one last question.
Yeah.
So the variables that we found right now, that 6.5